Hi, welcome to Learning Economics. First of all, again, please accept my apologies for the long delay in uploading this video. Actually, there were some things that were out of control, unforeseen, and because of those, the video got delayed. But from now onward, we shall upload 3 videos each week, one on Monday, next on Wednesday, and third video of each week on Friday. So with this announcement, let's continue our journey on visualization of the data from the point we left in the last video. However, if you have not watched my last video, I would request you to pause this video here and do watch the last video, the link of which is given in the description as well as above in the I button. So please do watch that, where I explained in very much detail how to create good graphs using R. This video is just a build up on that, and today we are going to explore some other kind of the graphs and try to learn what statistical properties of the data we can get from these graphs. So let's come on RStudio screen and see our work. Here we go. So here we are on the screen of RStudio, and as I told you in my last video that there are plenty of packages that you can use to create graphs, but we shall be using ggplot2. You can download the ggplot2, but ggplot2 also comes in a large package which is tidyverse. And if you want to download, I would recommend you to download the tidyverse. It will give you ggplot2 as well as other useful packages that we should be using as we go along this course. And moreover, I also told you in my last videos that if you have already downloaded any package, you do not need to download it again. You just need to call it to the library. So that's what I'm going to do. I am calling tidyverse to the library. And just wait. Yeah, so all these packages have come into the library. Now I am calling the data to the library, and I shall be using penguin data. So Palmer penguins, the data has come into the library. This has been loaded. Let's have a view on the data. This is, as I told you, a very good practice to look at the data first before doing anything else. So here, as you can see, there are multiple variables: species, Iceland, bill length, depth, flipper length, body mass, X, years. Some are numerical variables, some are non-numerical variables, or you can say some are qualitative variables and some are quantitative variables. We shall discuss these types of the variable in much detail as we go along the course, but at the moment you just need to know that qualitative variables or you can say non-numeric variables and quantitative variables or numerical variables. So let's just do a quick revision. Let's first create the scatter plot with a smooth line. So as I told you in the last lecture that how we need to go, we shall write ggplot, then tell what data to be used. So penguins. Okay, then we shall use aesthetic, that is what to go on x-axis, what to go on y-axis, the color and the shape, everything. And aesthetics are merged with the data or linked with the data using mapping function. So we will call mapping, okay, equal to AES aesthetic, and we shall tell simply that I need, for example, flipper length underscore mm on x-axis, and I need, for example, body underscore mass underscore g on y-axis. Very fine. I'm leaving the other aspects of aesthetic for the moment, but let's make them the part of the point. So I need to select the geometric object which I will be using to represent my data. And as I told you, I will be constructing the scatter plot. So I need geometric object point. Sorry, geom. Yeah, geom underscore point. And now I just want these points to be different as per in color and shape as per species. So I am writing color equal to species, and I am also writing shape equal to species. Okay, let me come out of this. So jump plot point aesthetic has been completed, and I hope you remember what difference it makes if I would have added these aesthetic into the previous layer, and what difference it makes if I add it to this layer, geom point layer. So next, as I told you, we also want a smooth curve. So geom underscore smooth. And for the method, let's give it least here method. So I hope everything is fine. So let's see. Yeah. So here we have the graph, different colors, different shapes according to species, and x-axis, y-axis marked, and scatter points, and a smooth curve fitting. Well, good. Last time we added some labels to this, so let's do that as well. So for example, I take this, I want to add another layer of labels. So I would write labs, which is for the labels. Just let me add labels. Title is equal to, for example, graph. Okay. Subtitle is equal to, for example, learning comics. Okay. And x-axis I want to write clipper length ENTDH in millimeters, and on y-axis I want to write body mass in grams. So we can also add a lot of more layers, for example, the footnote and others. So just leaving it for now. And you can see the title, subtitle, x-axis, y-axis, labels, and everything. So I hope we are now ready to move forward with some new graphs and learning some new techniques. So let's start with the bar graph. And for the bar graph, frequency is automatically on y-axis. You do not need to specify it. It's something automatic. You just need to specify what variable you are going to plot on the x-axis. So here I am going to plot species on the x-axis. So it will be quite a simple, like I would write ggplot, then data equal to penguins. Okay, and then mapping equal to aesthetic, and I will write only x-axis, which is species. Okay, and done. So just I need to add the geometric object. So I would write geom underscore r. Oh, sorry, it told me that you forgot to add the parentheses. Actually, just as I hit enter, I thought those bars should automatically appear. But anyway, so here we have the bar chart again. You can write the title, subtitle, x-axis, y-axis, and other things on that. This is just a simple, but if you are not liking that you want to change the width of these bars, what can you do? But let's do that experiment in the histogram. And for the histogram, let's use the variable body mass in grams. So for that, just let me change the variable over here, body underscore mass in grams, and from histogram. Yeah, first let's just go ahead with the flow, and then we see if we need to. So this is the histogram. Basically, the length of a bar in the histogram gives us the count, that is the frequency. So the highest bar shows the mod value of the data, and overall the shape of this graph gives us some idea about the distribution of this graph. So here in this graph, if we take the middle value, for example 4500, data is distributed to the right as well as to the left, but data is more skewed towards one side. So by the look of it, it seems as a skewed data, but that is for more for the statistical information. You can read about the skewness, the positive skewness, negative skewness, what are the consequences. You can read its details in statistics textbooks, or you can do some Google on it. But as I would just give you an overview of those properties. Now, the main point is that if I want to change this width of this bin, what I can do, I should just add that information at the end. So let me add that. I'm writing bin with equal to, let's say 20. Let's see what difference it makes. So it has now clubbed those 20, for example 0 to 20, and draw a one line, and then 20 to 40 and draw another bar, and 40 to 60 and another bar. And you can see that this looks at least more clear, more appealing, but gives us a better view than the previous one. But still, there, because there are a lot of variations in the data. So let's see if we increase the width size from say 20 to 200. So now here is that. Again, you can define the outline of these widths as we defined earlier. In our last lecture, we did some practice over it, and you can again add colors, labels, everything to it. So uh, that is all about this histogram. There is another graph that is very much closer to the histogram, which is density plot. Density plot, let's first draw the density plot, and then we will do some experiments with that density plot. So let me go here. Yeah, so again, uh, instead of histogram, I'm writing density. DNSITY. Yeah, and yeah, parentheses are there. So basically, density plot and histogram both give us same information about the data. The only difference is that in the histogram, we plot the data using bars, whereas in the density plot, we just give a curve. So the both give the same information about the data. You can see the data is spread around the mean, but the highest value of the data, which usually denotes to the mean, is not in the center of the data, but it is skewed towards one side. So it shows a skewed data, and we learned these insights about the data from the histogram as well. So it depends on you, or on the demand of your client, or the work that you are doing, whatever you choose. If you choose histogram, or you choose the density plot. But As we did with the histogram, with the size of the bean, here we do not need to play with the size of the bean, but we can play with the size of this curve. Should this curve be, you can say, its width. So let me play with its width. So I just write line width. Let's say I write 0.8. I don't know will it get more thicker or smaller, but let's see. Yeah, it's a bit more thicker. So now if we want to, again, like we did with the bar chart or other charts, if we want to make it more colorful, we can do that as well. We can add the color properties here. For example, we write color equal to species. What difference it will make? I'm sure you know it, but let me just make it for you. Outline of these have been adjusted as per species. But if you want not only the adjustment in the outlines, but you want these curves filled with this color, so you can fill equal to species. Now these are filled, but you can see the outline is in the black color. If you want both, you need to write both. Here it is. Now let's play with this density. If I am just increasing it to 1.5, oh, okay, so to 1, let's increase it to. You can now see the difference, that it is the colors are more thick. No color is giving any space to other. In fact, the color that is the brightest, that hides the other colors. But if you make it to like 0 point say 2, now you can see there is more transparency here. This property of alpha is more visible when you fill these colors and all those things. Now, something, uh, let's add one more thing to it. For example, let's suppose I do not like to have these labels of Adelaide, Chinsha, Ganto on the side. I want it within the graph. For that, what I need to do, I need to introduce another layer, which is annotate, and then I need to specify the position according to x-axis as well as according to y-axis. For example, let's say I want to add Adeli at this point somewhere. For example, at this point. So I will need to tell the x-axis coordinate, y-axis coordinate, and this word, what I want to write here, over here. Let's say I want to add chin sharp over here. So I would need to tell y-axis value, x-axis value, both coordinates, and again this. Let's try doing this. So let me go to this previous, and we can add annotate. I am just adding some text. So I would write plus annotate, and in annotate I'm writing text. Let me go to the next line, please. That will, oh sorry, just excuse me. Let me move to the next line. We can continue this in multiple lines. So I am writing annotate, and in the annotate, let me write text first, that we are going to give it a text. Okay, and as we have told that the text is coming, so what should be the position of the text? Let's say we add it at 3000 on the x-axis, and maybe at point 0015 on the y-axis. So x is equal to 3000, y is equal to point 0015. Fine. And then what should be the label, or what I should write over here? I am using label is equal to, again, ADELIE, Adelie, inside the inverted commas, so that it should know that it is a character, and it should uh, place it as it is. Okay, label is there. So what color should I, if I want to specify any color, and its color equal to red. Yeah, it will change the color. And let's say I want to bold it as well. So font face is equal to bold, italic, whatsoever you want to write. If you don't want bold, don't write it. Or what should be the size? Let's say size should be 1.5. So all this is just for one annotation. What you can do is just copy it, paste it, and just change. For example, I want it to be at 4500. So this is 4500. Okay, and this is chin, CHINSTRAP. Color, I want green color. So green. Okay, all that is fine. In fact, I have changed it in the previous layer. No, but that will not be an issue. So next, let's add the third layer of it. Annotate and just change. So now we want add, for example, 4500, 3000. Let's say we want it at 5500 on the X, so that it is somewhere in between this line. And let's say we want it to be at 0.001, a little bit below the and Gento, and its color, let's say blue. Okay, and let's say size maybe 2. Okay, so you just need to add a plus sign over here. Another thing that I need to, yeah, load the plus from here, but it's not happening. Okay, so let's go. Okay, bold is not found. Why? Oh, let me correct it. Where is bold? Bold, yeah. So it is looking for an object, but it is not an object, it's a property. So let's tell it why it's nothing. It's not an object. It's the property that you already have. It's characteristic. It's some property. What's that? OKGG cognitive object together. Just, just let me fix it. Okay, here we were. Here we are. Annotate. This fine. Let me take it to this. And yes, you can see there is Adelaide. This is Chinsha. This is Gento. These are too much high. So let's instead of this, let's put it here. Maybe 2. Okay, and this as well here. Okay, and the text size 1.2 looks 1.5 looks very small, so let's make it, for example, 3.5. Let's make it 3.5 as well, and let's make it 3.5. 3.5. So what we did now, we actually lower down the position of these two. This one, the red color one, we lowered it down to y 1.0, like somewhere here. For this, we lowered it to 1.002, a little bit above this line, but definitely below this current area. And this, we can also decrease it to as to somewhere like 0.0085. So let's do that as well. 0.085, 0085. So let's go. This looks better. But now, as I do have these labels within my graph, so what's the use of having those labels outside? I should not have those labels. Okay? What do you say? So for that, let's go to the previous. Let's make this small, very, very small change. In fact, we just add that we do not want this layer, and this layer is, by the way, part of the theme layer, and these are called legend position. So I am writing theme legend position, legend dot position, or what I should write, just yeah, legend dot position. It actually controls where your legends should appear, and I just want them nowhere. Legend position is equal to none. That's nice. Legends have disappeared, and now my graph looks better. I can change the position if you want all of them at equal height. You can place them at equal height or wherever you want. Just maybe did some experiments. But let me just add one more thing, and then I will tell what difference it made. So on the line, just I add one thing, team underscore minimal, and just leave it at. Note the appearance of the graph, and now I have added one more layer and see what difference will it make. Yes, it has removed many of those colors or lines, but it should also remove the legends. Legends should not be appearing over here. We can yeah, those are gone now. I have just repositioned them. I think that should not have made any difference, but if that makes, you can play with these repositioning and get your graph. It has it has vanished all those details that we did and that were not related to this graph. So the colors were removed and other things were removed, and it applied a minimal theme to this. And we have a nice, excellent graph where we can write the commentary and anything else. Now, as we have done with this density plot graph, so let's see if we can how to draw a box plot. First, we draw a very, very simple box plot. What is box plot used for? Just let's first get the box plot, and then we can discuss its properties or its statistical features. And as you know, on the box plot again, we use the existing data, its frequency, and some other like first quartile, median or average, and fourth quartile, and other properties by default. So we just only need to give what variable we are representing, and that the value of that variable according to which we draw the box plot goes onto the y-axis. So you just need to know a little bit about the graphs first, that if this graph has some x-axis or it has some y-axis or it has both axes, you need to have a good understanding of it first. Then of course you can use R to draw all those kind of graphs. So let's make the box plot first. So again, ggplot, and data is penguins. Okay, and then mapping, of course. Yes, we do not need to specify the x-axis. We just need to specify the y-axis over here. I am using body mass in grams, so I am just writing body underscore mass. Why it's not giving? Why it should? Body underscore mass underscore. Yes, it's appearing now. Thank you. As per my geometric object, because I want to draw the box plot, so I will be writing box plot. Just leave it empty for now and look at this box plot. What are the boundaries? What they specify, for example, this lower boundary, what this upper boundary specify, what this line tells us, what is specific about the length of these lines. I am just going to tell you all these details, but for now, just have a look that we have drawn a box plot simply by just telling it what should be on the x-axis. But if I want different box plots for say different species, then I can mark those species on x-axis. If I mark those species on x-axis, it will create three different box plots, one for each. So let's just do it. Y is this and X is species. I hope it should not mind this arrangement, but let's give it a try. Yeah, so we have three box plots, one for Adelaide and Chinchamp and then Gento. And on the middle of this box plot, on this middle one box plot, you can see there are two dots. So what these dots are for. Just hold on these questions. Just hold on. I am just going to finish this exercise and then I'm going to tell you all these in detail. So here are the box plots. Just one more, and then of course I'm going to tell you more about the box plot and some other things before closing down this lecture, that is volume chart. So for the volume chart, I am using same, that is I am just adding geom instead of geom box plot. I'm just adding this. So here you can see these, but you do not like much of these very simplistic colors and you want them to be a bit colorful. Yes, we can do that. We can always use color that will just color the outlines differently. We can use the feature fill that will fill the area with the color, and if we use both of them, it will do for both. So let's just do it for fill only. So and you know the colors and all these are part of aesthetics. So let me just change and make a change here. So fill is equal to species. Okay, so yeah, so we have these species. If you now if you want to remove this legend, and then you know how to remove that legend, you can just write the theme legend and then tell it that I don't want any, so I just want none. So it will remove that as we did in the previous. Just Just one more thing I want to do before I finish. Just have a look at these shapes, and I am going to add one thing here, and it will have some impact on these shapes. So what is that one thing and what impact? You just need to know that. So here I just write trim equal to false. As you will write, false will start appearing. So just note. Now you can see there is some difference at the end of each shape it has made. So you can read more about the trim by googling it or by using the help menu in the R help on the ggplot. So that will tell you more about it. But for now, we are closing this series. Just I'm giving you an overview of the box plot, what it tells us, and also volume. So these both. So let's talk about box plot first. So this is a shape of a box plot. Here you can see a box plot basically gives us an idea of various statistical properties uh, of a variable. For example, if there are dots appearing towards the lower end or towards the upper end, that basically shows that there are one or two or three outliers in the data, and those outliers are towards lower end or towards upper end first. Then the boundary line of this box gives us 25th percentile, that is Q1, first quartile, and 75th percentile, that is 75th percent of the data, which is Q3. So that marks the boundary line of this box. The line inside the box is placed at the median value. So the box starts from Q1 or the 25th percent. Then there comes a line inside the box. It is the median, that is the 50% of the data, and then the upper boundary, which is the percentile, 75th percentile, or it is Q3, that is third quartile of the data. Its length are adjusted using mean plus 2 standard deviation, or mean plus and minus 2 standard deviation, that basically adjusts its the length of its lines upward as well as downward. So this is all about the box plot. It gives you very useful information. Now violin plot actually mixes the elements of a box plot and a density plot together. So you can see it creates a density plot around the box plot, and the boundary line of that density plot is created as per 95% confidence interval. So this is all about box plot and the violin plot. We are ending our series on the visualization of data here, but it is not the end of the visualization. Now I believe that you have all the basic information about the visualization of data. You can practice it well, and if you want to have some advanced visualization, you can build up that based on this knowledge. You can read that from RStudio help, or from you can Google it. Once a code will appear before you, you will be in better position to understand that code. In the next lectures, therefore, we will move ahead on the data analytics, and we will cover two very important very important functions. One is filter and other is pipe. And then we will, of course, study the correlation, covariance, and other types of those small statistical values that help us better understand the data and get some meaningful uh, and and help us get some meaningful insights about the data or about the variable in the study. So thank you for taking your time watching this video. Please, if you like these videos, please do give a like, do tell us in comments, and do tell us where you want us to improve. If you find these videos helpful, do share it within your network, with your friends, and with your students, with your fellows, etc. So, see you on the as per our new schedule. We shall be uploading 3 videos in a week: Monday, Wednesday, and Friday. So, see you in the next video. Take care. Bye bye.